Cradled in the lap of the majestic Himalayan mountains, Kashmir Valley is crowned as heaven on earth. In spite of looming threat of terrorism, Kashmir is undergoing a paradigm shift in its developmental activities, connecting its vast inaccessible areas, bringing boons of technology and benefits of civilization to snow-capped mountains and beautiful landscapes. With aim of connecting Kashmir to Kanyakumari via railways, construction of Udhampur-Srinagar-Baramulla new BG Railway Link project was undertaken by Konkan Railway Corporation Limited to improve interconnectivity within state of Jammu and Kashmir. Dealing with difficult terrain, harsh climatic conditions, snowfall and severe winds throw steep engineering challenges that pose a threat to this national project. The mountain ranges along Chenab River Basin are made of sedimentary rocks, which is very different from rock quality experienced by KRCL in the Western Ghats. Work stretch of 22 kilometers in the hilly terrain with poor rock formation, landslides during monsoons, and similar other geotechnical issues were worse challenges. In addition to these, remote and inaccessible locations with narrow and heavy steep gradient and almost no road condition constituted tremendous communication constraints. Availability of resources posed a problem with the nearest city Jammu being 125 kilometers from Batli camp project site. KRCL awarded construction work of tunnels T6, T9, T10, T11 and T12 between Kauridugga on Katra Dharam section to ITDC Cementation India Limited, a company with more than 8 decades of expertise in design and development of infrastructure in India.
Tunneling in India is always a challenging task, but if it is in Himalayas, then it becomes more difficult. To overcome these things, we made an extensive planning. We have mobilized a state-of-the-art equipments so that the work can be done smoothly. We have also engaged experienced and trained engineers along with the experienced technicians for safe and hassle-free work.
Comprehending challenges of this project, ITD Cementation India Limited brought in a huge pool of qualified personnel commensurate with required expertise, including geologists, surveyors, civil engineers, mechanical and mining engineers, safety engineers, and other technical experts to handle any situation and provide quick and efficient solutions to problems as and when they arise. All major high-tech equipments and machinery required for this project have been imported and some designed and fabricated in-house by ITD Cementation India Limited. Specially imported machines like Sika shotcrete machine and twin boom jumbo drill machines are important machines of tunneling and require regular maintenance from skilled mechanics. State-of-the-art workshops are equipped with all required machinery and skilled workforce to handle any type of breakdown of machines and equipments. It reduces idle time of machines and improves cycle time of tunneling activities. As a result, ITD Cementation is in a position to address any issue immediately concerning machinery during project execution, saving time, cost and eventuality. Tunnel excavation is being done following NATM method, wherein systematic analysis is done of rock quality and systematic support system is provided as per classification of rock by expert geologists. For classification of rock mass, Q value system is followed.
Geologically, our project lies under a very young formation. There is a sedimentary rock and main type of rock we found under tunnels. It's a sandstone, siltstone and claystone. But dominant rock is siltstone. It doesn't have a good strength.
Each and every aspect of tunnel construction is monitored. If a problem crops up that cannot be solved at site, headquarters is informed and response time is immediate. More experts arrive and together with existing bandwagon, they put their heads together in finding an immediate solution. The The first step undertaken in this project is creation of approach roads to sites of operation. Base camp is set up at a suitable location near project site, followed by site office. For every tunnel to be constructed, operating sites are identified and set up by installing necessary infrastructure, machinery and equipments. Before actual tunneling process starts, false tunnel section is excavated and RCC lining is done, and then actual tunnel excavation begins. Actual tunneling starts with portal construction, with size greater than actual tunnel size. Pipe for pawling with high pressure cement grouting is done for roof stabilization. And then actual face drilling starts with twin boom jumbo drill machines, followed by charging and blasting with explosive drilling. Blasting is carried out from center in small units for a distance of 10 to 15 meters, creating pilot holes. Eventually, the full shape and size of the tunnel is achieved. Now, repetitive tunneling method begins. Geologists and surveyors analyze class of rock after every round of blasting operation and find Q value and RMR value. Depending on the class of rock, rest of tunneling steps to be undertaken is formulated. Geologists and surveyors collect data with help of profiler machine and plot them on paper. Charging patterns change with change in rock class. Based on this data, drilling and blasting pattern is prepared. Drilling and blasting is carried out as per design pattern. These, along with charging pattern, is the heart of successful tunneling. It is followed by defuming for about 30 minutes. Water is sprayed all over blasted surface to settle dust and to reveal cracks and fractures. Next step is mucking. Once muck is removed using excavator, geologists and surveyors again evaluate region, provide support system design and collect data for the next blast. Primary shotcreting is done with robo-arm shotcrete machine. Rock bolt drilling and grouting is done as per rock bolt design given by geologists. Depending on rock class, plates are fixed and bolted and predefined amount of torque is applied. Rock bolts are then tested for load-bearing capacity after 15 days. As per requirement and based on geological evaluation done by geologists earlier, preliminary support structures like wire mesh or lattice girder may be erected, after which final layer of shotcreting is done. The process is then repeated for next round of blasting as per the requirement. Monitoring of critical aspects with instruments such as extensometer, pressure cell and load cell are carried out after every 10 meters of tunneling. If there are any variations or problems, adequate steps are taken to correct them, like changing supports and so on. Following this methodology, tunnels 6, 10 and 11 are being constructed from both ends, while tunnels 9 and 12 are being constructed from one end. In case of tunnel construction from both sides, when 10 meters is remaining in between, a central hole is drilled from one side to the other to check and maintain alignment. Then one side is closed and digging is completed from the other side. For rock class 3 and above, the tunneling is done first with heading, and then in the same process, benching is completed. Once tunnel has been excavated from one end to the other, entire tunnel is cleaned. Geologists evaluate and survey once more. Gantries are introduced into tunnel if possible, from upward direction to downward direction. Geotextile membrane and waterproof membrane are fixed to a certain no seepage water comes after lining. Kicker gantry pours concrete on two sides, creating side slabs. Perforated PVC pipes are embedded into them. Then kicker gantry moves forward. Main gantry is then fixed, which pours concrete by pumping and completes concreting process. Once entire tunnel is completed, kicker gantry and main gantry are dismantled. After that, floor is washed and cleaned. RCC concrete is poured. In this way, kicker arch and invert concreting are completed. All the portals are finally stabilized with required support measures to ensure no loose fall occurs. Due to adverse geological and weather conditions, safety plays a critical role. Risk assessment of each activity is done in advance, and controlling measures are also taken to reduce risk from technical or administrative measures. Regular toolbox talk, training and induction are routine jobs. Complete injury-free site with zero accident is the set goal of the company. Due importance and care is given to environment and ecology of nearby site area by safety department.
Our site target, zero accidents. For achieving the target, we done risk assessment, training, toolbox talks, periodical audits to check our system to enhance the project.
Following this methodology, ITD Cementation is carrying out tunneling work of 5 of 43 tunnels to be constructed in this region, with the recent addition of tunnel number 1 passing through Resi Trust in its basket. The USBRL project is perhaps one of the most difficult engineering projects undertaken since independence, with great strategic importance of both economic and military nature. Once completed, it will be a feather in the cap of Indian Railways and another great milestone reached for ITD Cementation India Limited.